Okay, screen is visible to you, everyone. I have not written anything over here. So this blank page, is it visible?
Yes, sir.
Okay, great, fine. So now I will take the problems directly. So those things I will send it to you later. Okay, so you can refer it to them. So before we start with the actual problems, so first let me give you a few hints here. So based on which we will be discussing few problems. Okay. So okay. Okay. So now so far we have discussed the waveform synthesis. Okay. So the main thing what you need to observe here onwards is, see, whenever in a given signal, so if you have a signal, any arbitrary signal, okay, so if you have these kind of things, and you may have these kind of things, and again you may have these kind of things, and after a gap also you may have these kind of things. Okay, so here at every point you need to analyze this is which signal.
ಎಷ್ಟು 17 16 ಸಾಕು.
Okay, see, whenever you are checking these things, so here you can note that this is a ramp signal. Okay, now this is like it is built up with some step signal, and again you have one more ramp signal, and here you have no signal, that is zero, and again you have the step signal. Okay, okay, and if you have any random slopes like this, so here everywhere in these kind of things we prefer the ramp signals. Okay, understanding this concept here. Okay, so now if I take up a few problems here now, so let me take the first one over here. the color here. So this is 0, and we have the signal like this. At 1 it is at 3. Okay. Let me check it once again. So for 1 it is 1, for 2 it is 2, and for 3 onwards it is 3 over here. So just check, and maximum amplitude what we have is 4, so then it is down. Okay, so this is the given signal over here. Understood this one? Okay, so just let me write here the magnitude over here. This is 0, this is 1, 2, 3 and 4. Okay, so if you just observe, so there is no signal from 0 to 1. Okay, so from 1 to 2, so there is a step signal. So let me mark like this. So from 2 to 3, again there is one more step. Then 3 to 4, there is one more step. Then 4 to 5, so there is step like this. Okay, so totally I have marked 4 arrow marks, and at each point you just measure the or notice the magnitude. What is the magnitude here at this point? Magnitude is 1. And what is the change in magnitude here? Everybody just observe here first. What is the change in magnitude? It is 2. It is with how much units? It is with the unit of 1, right? So anything which is going upwards in the step signal, you take it as positive, and any magnitude given like this downwards, you just assume it as negative. Okay, so here to here change is how much? 1, and here to here change is how much? Magnitude is 1, and here to here the change in magnitude is 1. But here to here the change in magnitude is how much? 4 minus 0. This is 4. This is going downwards. Okay, understanding the signal property here, everybody? Okay, so I'm telling you the shortcut method here. So within just 2 or 3 minutes you can get the actual signal. So I can have the same thing. This is F1, F2, F3 and F4, and this one another step which is going down. So this I will take it as F5 of T. Okay, so how to define these things? So first one, F1. So if you just consider F1, where it is starting and where it is ending and with how much magnitude it is there. Okay, so that we have learned in detail. So now how to write it directly? So 1 to 2, what is the magnitude? Between 1 to 2 magnitude?
1.
Yeah, so magnitude is 1. So you write f of t is equal to 1, and it has started from which point? It has started from t equal to 1. So I can write u of t minus 1. That's all. So this will define the entire f1 of t. Okay. So similarly, now if you take f2 of t, so on the same basis, now please be careful here with this shortcut method. Magnitude is 2, but earlier you were here at this step. Then what is the change in magnitude? Change in magnitude is 1. So you should add how much to get 2 here? Earlier is 1. Now again you have to add 1 yes, am I audible or no?
Sir.
Okay, so there is some network issue, maybe again. Yes, are you able to see the screen?
Yes, sir.
Okay, fine. So now you have to describe this f2 of t. So how we have discussed this? So first thing is you just look at this point. What is this f1 of t? Okay, so it is having the magnitude of 1. So that means I can write u and it is starting at t minus 1. So similarly, if you take f2 of t, so f2 of t, it is starting over here. So this one. So this is again the magnitude is 2, but with reference to the previous magnitude, what is the change in magnitude? Change in magnitude is 1, right? So you have to add that much amount of magnitude. 1 plus 1 will be 2. 2 times u of t minus 2. Okay. Similarly, f3 will be what now? f3 of t. What is the magnitude? 2. Okay. What is the previous magnitude? It is 2. 2 plus 1 will give you 3. So I have to add u of t minus 3. This is the shortcut method what I am telling you. So in the previous class I have told you the detailed thing, starting point and end point. So that we are not using it here. Okay. Then if you come to f4, so if you come to f4, so it is here the magnitude. Okay. So f4 of t, that will be again, what is the change in magnitude? U of magnitude is 4, change is 1. Suppose if I had written here like 5 instead of 4, if I write 5, then you can write here as what now? 2. So shall I write that? So let us take it as 5. So change in magnitude will be 2. So we can write 2 times t of minus 4 because it is starting at this. Now if you consider the magnitude to be 5, so here to here, how much is the difference? You have to end it. So the signal is starting at 4 and it is continuing, but you have to end it at 5. You have to bring it to 0. So in order to bring it to 0, you have to add the another signal whose magnitude should be how much? It is 5. So 5 means you have to add minus 5 u of t minus 5 if this is 5. Okay, are you getting this?
Yes.
So don't have any confusion over here. So signal was starting at 1. So look into the function 1. Magnitude is 1. Earlier it was 0. So difference is again 1. So I had added 1. 1 into u of t minus 1. Come here. 2. 2 into the, sorry, not 2 into. 2 is the magnitude. Change in magnitude is how much? 1. So where it is occurring? At 2. U of t minus 2. Come here. This is having the magnitude 3. Change in magnitude is 1. So we are adding 1 here. So it will be starting at 3 minus u of t minus 3. So these are like these signals. First one is u of t minus 1. This is u of t minus 1, which starts at 1. Another signal is u of t minus 2, which starts at 2. Third signal is u of t minus 3. So if you go on adding with respect to the time values, you will be getting this one only. Okay, getting that?
Yes.
So finally you have to add all the 5 signals. Okay, so I will send the details, but right now you understand how to represent it in time domain. Okay, later you can convert it into frequency domain, right? Say for example this one, this is what, e to the power minus 5s divided by s, right? So this will be f5 of s. Okay, so these kind of questions you will get for minimum 5, maximum maybe 10 marks also. So let me take the second one. If you have the signal like this, so this signal which we discussed earlier, okay, which is having okay. So how to understand this completeness of this signal? So let me write here. Even though it is given like this, so you start from left side. Is there any signal? No, 0. So you come here. So you are traveling upwards. So now there is a positive ramp, this one. Now this is negative ramp, and it is ending here after 4. Again it is 0. So what you have to do is, since there is only 2 ramp signals, so you have to start from here. So start here from the left and stop here. Okay, so how to analyze it? So first what you have to do is, you have to say, just for our understanding, if I mark this point as A, this point as B, this point as C, and towards it is ending at D, if you assume. Okay, so A to B, how it looks? It is a ramp signal, positive ramp signal. So you have to identify the slope here. It is positive ramp. So if you take the A as the starting point and this as the ending point, okay, so here you can mark x1 y1 and here you can mark x2 y2. So what are x1 and y1 values? This one, this point
0,
is
0.
0, comma
0 comma 0. This one is, B point is what?
10,
You have to travel 2 units along x direction.
2, comma 10.
10, yes, 2 comma 10. So slope will be how much now? Y2 minus y1 divided by x2 minus x1, right? So that will give you the value as 5. So
5.
this line slope is, you can write it as plus 5. Similarly, you measure the slope here as well. So that is from B to C. Now this will be the starting point. This will be the ending point. These coordinates we know, this is 2 comma 10 and this is x is 4, y is 0. So this slope will be 0 minus 10 y2 minus y1 divided by x2 minus x1. So this will be minus 5. So this slope will be minus 5. Okay, is that clear, this point first?
Yes, sir.
Okay, now here you were at 0, again start here, you have raised here. So what was the slope? Plus 5. So you have added 0 plus 5. Okay, so you remember this slope over here, you have to keep an eye over here. Now from point B you are going down, it is a downward journey. Earlier your slope was 5, your slope was plus 5. Now B to C you have to get a slope of minus 5. So how much you have to add here to get minus 5? You have to add a value of minus 10. Getting that? Yes, getting this. This is for AB, this is for BC, this is the slope. This I will tell you where you have to add. Just keep these things now as it is, you will understand. Okay, now here what is the slope? B to C, it is minus 5, and here C to D it will be how much? This will be 0. So minus 5 is there. To get 0 what you have to add? Plus 5. So you remember these values. Okay, now we will go into the modeling here. So first thing is, if you check the given thing, and if you just plot them those things as it is, so I can say that this is made up of three functions. This is f1 of t, this is f2 of t, and this is there f3 of t. Okay, so the given function is like this. So some function f of t, if I assume this is f1 of t plus f2 of t plus f3 of t. So f1 of t, where it is starting, and it is which kind of signal? It is a ramp signal, right? So it is a ramp signal. Where it is starting? Where this ramp is starting? It is starting at 0. So that means t minus 0. So you can write t. And what is the slope here? Y equal to mx plus c. What is the m value? What is the slope?
5.
5.
5.
So at 5 r of t, and here you are having the previous slope as 5. Now b to c, so this is a to b. Now for b to c, how much slope we should get? Minus 5. Already we have 5. So to get from plus 5 to minus 5, how much we have to add? Minus 10.
Minus 10.
This point, is it clear? This is very important. Is that clear now, this one?
Yes, sir.
And this B to C journey, it is starting from which point? Which timeline? T equal to 2. It is a ramp
2.
signal. So I can write it as R of T minus 2. Is that clear, everyone?
Yes, sir. Yes, sir.
Next, which is the next point? C to D. D we don't know where it is ending, just I have written D. Okay, so what is the nature here? This ramp was running, so this has to be stopped. So you have to make it 0. From which point you have to make it 0? So from point 4. So that is R of t minus 4 you have to do. But slope should be how much? Slope should be 0.
Plus.
So previous slope was how much? Minus 5. So to make the slope as 0, what you have to add here? Plus 5.
Plus 5.
Okay, is that clear now? So
Yes.
its Laplace transform will be how much? 5 by s square plus 10 to the power e to the power minus 2s divided by s. This is minus. Okay, then plus what you have to add? 5 e to the power minus 4s divided by s square. This is the answer. So if you do these things properly, you will get minimum 7 marks. Minimum 5 to maximum 8 or maybe 10 also. Is this clear now, this method?
Yes.
Yes, sir.
I will send you the details, but you need to work on this. So let me take the next problem. Third one. So if you have a signal f of t given like this, zero, 1, 2, 3, 4, 5 like this. Okay, so the signal is mentioned like this. This is the signal. Now how to model this? You start from the left side. So till 0 there is nothing. So you can see here 0 to 1 no signal is there, but magnitude is 0 and change in magnitude is happening from 0 to 1. How much? What is the change in magnitude? It is 5, right? Okay, so this is a one function. I will just call it as f1 of t for a while. Okay, this is what now? Again a ramp. See, till you get perfect, just mark like this a, b and c, and it is ending here also, so you have to make it 0, not necessary 5. So after 3 it should be 0. Okay, so 1, 2, 3. You tell me the slope of this. What should be the slope? Starting point coordinates 1, 5.
1,5.
Ending point x is
3,
3.
0.
Slope will be how much? 0, y2 minus y1, 0 minus 5 divided by 3 minus 1 minus 2.5. This is the slope of this line. But what is f1 of t? f1 of t is a unit step signal which is started at 1 and ended here itself. So it is like a unit step signal. So how we can write this unit step signal? It is having a magnitude of 5 which starts at t equal to minus 1. Okay, then f2 of t, it is what kind of signal? It is a ramp signal where it is starting t equal to 1. So I have to write t equal to minus 1. What is the slope of that ramp? It is minus 2.5. And now change in slope is there, that is 0. So previously it was minus 2.5. So from where you have to make it 0? Ramp. It should be made from 0.3. So how much you have to add here? The slope to make it 0. So this line should not continue like this. It should be made 0. So how much you have to add here? Minus 2.5 was there earlier. So you have to add plus 2.5. Okay, so yes, getting that? So this value will be minus 2.5. So overall f of t will be what now? Addition of all these things. F1 of t plus f2 of t plus f3 of t. So you just add them. What is f1? 5 u of t minus 1. F2 is minus 2.5 r of t minus 1. F3 is okay. So this is plus, sorry, not minus, plus 2.5 of r of t minus 3. So what will be f of s? 5 e to the power minus s divided by s, and this is minus 2.5 e to the power minus s divided by s square plus 2.5 e to the power minus 3s divided by s square. Is it clear to everyone?
Yes, sir.
Getting no this one problems?
Yes.
Now fourth one, if I give you like this, the signal is given like this. Now you identify the kind of signals you have to model here. So this is one signal which is going upwards. So it is which kind of signal now? Change in magnitude is happening 0 to 5. So it will be a unit step signal which is having the magnitude as 5 and it is starting at 0. So this is the first one. Second one is the 5 to 3. So this is the second one, which is a ramp signal. And what will be the slope? So 5 to 3 also we can take, or 5 to this point also we can take. Slope will be how much? So if I take any coordinates, this one or this one, so this is x1 starting point 0, 5. This one I can take it as 3,
3,0.
comma 0. So this will be minus 5 by 3. Okay. So now this entire line slope will be minus 5 by 3. So if I mark this as A to B, A to B is minus 5 by 3, right? So now this ramp has to be stopped here. So we are going upwards. So to what was the previous slope? Minus 5 by 3. So to make it 0, what you need to do is you have to add plus 5 by 3. Okay, at 4. Okay, so once it is 0, now what you have to do is you have to check here. Now there is another unit step signal which is starting at -2, but it is growing upwards. So if it is upwards, you have to take it as positive. Okay, so it starts at timeline 4. So if I start from defining this function f of t, first this function, first one, then second one is this, then third is change in ramp, then fourth one is this. Okay, so first one, how do we write it? Magnitude is 5, it is u of t, it is like this. Okay, this signal is there, fine, at 0. Second one is what? Minus 5 by 3 is the slope, and this ramp is starting at which point? It has started at 0, right? So I have to write r of t. Then you have to cancel this ramp at which point? 4. So what you are doing, you are adding plus 5 by 3 at r of t minus 4. Then here it is cancelled, so here to here there is a upward unit step signal is there. What is the magnitude? Magnitude is 2. You just check the magnitude, don't worry about the sign. So where it is starting? At 4. So you have to add that signal with the magnitude 2 u of t minus 4. Okay, getting this, everyone? So
Yeah.
this will be 5 by s, this is minus 5 by 3 into 1 by s square plus 5 by 3 e to the power minus 4s divided by s square plus 2 into e to the power minus 4s divided by s. This is the Laplace transform of this signal. Understanding this? So how these signals have
Yes, sir.
arrived? So I have told it in the previous class. So that detailed thing I have told you. This is the shortcut method anyway. Fifth one, just try this for 1 minute. So if this is the given signal like this, so first what you have to do, first to understand the magnitude, minus 5 to 5 is there. This one, if I mark it as a to b, it is a downward ramp. So here the coordinates starting points are what? x1 y1, and here x2 y2. So what will be the slope? Minus 5 minus 5, 10, 10 divided by 2, this will be minus 5. Getting this? This
Yes, sir.
is minus 5. So B to C. So B to C, there is a change in slope. It is going upwards. So the turn, if you see, upward turn, and this one is downward turn. So downward turn always should have minus. So this one, so this starting point here, coordinates are 2 and minus 5. This one is 3 and
0.
0. So this will result into what? This is ending point. Start from here. 0 minus 5, that will be plus 5, divided by 3 minus 2 is 1. So the slope is plus 5, positive. And this slope will be 0. So the thing here is you have to add the signals. So this is a unit step signal here, straight line wherever you get. So change in magnitude whenever see. So 0 is there. Change in magnitude, now it is 5. So it is a step signal always. You remember this. Okay. Magnitude to magnitude change where it happens, no. So there step signal must be there. Okay. So f of t, what I can write, first one, this signal, that is 5 into u of t. Then this is second signal. So what is the slope over there? Minus 5. Ramp is starting at which point? This ramp is starting at 0. So I have to write r of t. So now come here. This is another ramp. Previous value was minus 5. Now we have to get how much? Plus 5. So minus 5 to plus 5 means how much you have to add here? Previous slope is minus 5. Next slope is plus 5. How much I should add
Plus
here?
10.
Plus
Plus
10.
10.
You just make a habit of writing like this. Okay, 10 into where it is actually the signal is arriving. So it is from 2, starting point. So r of t minus 2, right? Now previous slope is 5, you have to make it as 0. At which point? 3. It is a ramp signal only. You have to stop it. The ramp signal which is moving here at 3, you have to stop it. So what you have to do? How much amount of magnitude you have to add here?
Minus 5.
Plus
Minus 5.
is here, so you have to add minus 5
Minus 5.
r of t minus 3. Okay, getting this?
Yes, sir.
Yes, sir.
Yes, sir.
So can you write the Laplace function, everyone? Any difficulty over here? Now we have already done r of t minus 3 and all. So just write the Laplace function so that I can discuss few more signals. Is getting this, everyone? Enjoying the problems or no?
Yes, sir.
Yes.
Yes, sir.
Okay, good. This was fifth one. Sixth one. Now you model this quickly. Let me give you the signal in red color so that you can identify. So how to model this here? You travel from left to right over here. What is the magnitude here? This one which I have marked with the thick line. Magnitude is 0.
0.
So now change in magnitude is happening, but it is happening in the downward direction. What is the change in magnitude? It is 10. Since it is downwards, so we will take it as minus 10. Okay. Now here to here, what you have, which kind of signal?
Ramp.
Ramp
Ramp.
signal.
So what is the slope here? Same thing again, check the coordinates. See, until you get perfection here, so always practice this. Nobody is born genius, so you have to practice. X1, Y1, starting points are X1, Y1, 1, comma, minus 10. Ending points are 2, comma, minus.
Minus 20.
So slope will be what? Minus 20, minus of minus 10,
Minus
2, 2 minus 1. So that will be minus 10. So minus 10 ramp is going like this. So you have to hold it. You have to make it 0. So here, what you have to add?
Less 10.
Yes. So you have to add plus 10. At which point? At 2. Before you write the equation, you need to analyze this. Okay. Now, what is the magnitude here at this line? Don't check the slope only. Check the magnitude. Magnitude is 20. Okay, minus 20. Okay, number if you take minus 20. Now change in magnitude is happening. So what is the difference? 20, right? So whenever there is a change, so you have to adopt which signal? Unit step signal or step signal. Okay. So based on these things, so first again, if you write this f of t, so what you get now? This is 0, no need to write here. Change in magnitude is happening here to here. So from where it is happening? It is happening from t equal to 1. So it is like u of t minus 1 with how much magnitude?
Minus 10.
Okay, so write it properly. So at 1 only, again there is a ramp signal. What is the slope of that ramp signal? It is also minus 10. It is starting at r of t minus 1. Then it should be stopped here. This ramp which is flowing like this, no? It should be stopped. So to stop that ramp signal, what you have to do? You have to add plus 10. So whenever ramp is there, so now you can see, you can observe from the previous problem. Whenever ramp is going continuously, if there is a change in the waveform, so you have to stop that. So you can observe here magnitude what you have. So the opposite value we used to add here, right? R of at r of t minus 2. Then again here to here, what is the magnitude? Change in magnitude is in the upward direction, so it will be plus 20 u of t minus 2. So you write the f of s for this. Okay, getting this?
Yes, sir.
So just if you give me just some additional 5 minutes, few more things I would like to discuss and wind up. Time is 3:53, but I wanted to discuss few things. Okay. So anyway, now if I already we have discussed this one. Which one? Second problem we have. This one we have taken. So if we have a continuously like this, so how to model? So this is 7th problem. I will give you a few assignment problems as well. So be ready for that. So just observe carefully. Everyone, are you in line or no? 51.
Yes, sir.
Sir.
Concentrate here, please. Okay. So if you have a signal given to you like this, so here if it is 0.5, 0, 1, now this is 2. Observe here, it is 2 and 4. So how to model this? Now after solving these problems, start from here 0. So no change in magnitude, it is 0 only. So ramp, what will be the slope? Directly can you tell me? Delta y by delta x. 3 divided by 0.5. And it is a positive slope anyway. Right? So that will be how much? 6. So the slope is 6. And here, how much will be the slope? Delta y is 3 only. So 1 minus 0.5 is again your 0.5. I am doing it directly, or you can check the other method also what I have told you previously. So this will be, since it is going down, you can write minus 3 by 0.5, or this slope is how much? Minus 6. Getting this? Or you can put the coordinates also 0, 0. Here, how much it is there? X2, Y2. 0.5, 3. 3 minus 0, 0.5 minus 0. Same thing. Getting this, everybody?
Yes, sir.
So again you have now second one more slope, but now check the difference. This is 3, 2 minus 1, 1. So this will be plus 3. And what about here? This slope? 3
Minus 3 by 2.
minus 3 by 2 or minus 1.5. This will be minus 1.5. Shall I write it directly or you want the details? Here to here, this slope. 2 and 3 are there, x1, y1. So this is 4 and 0. 0 minus 3 divided by 4 minus 2. That will give you minus 3 by 2. Okay. And this is 0. First you make out these things. Then you start from here. What is the slope? What is the slope here? 6. It is which signal? Ramp signal starts at 0. You write R of t. Then change in slope is how much? Change in slope is how much here? Minus 6. So we are at plus 6. So how much we have to add to get minus 6? We have to add minus 12 at R of t minus 0.5. These are gate questions. So still this line holds the slope as 6. How much we want here? 3. So minus 6 to plus 3 means how much you have to add? Plus 9.
9.
At which point ramp is starting? R of t minus 1. So here the slope is 3. You want minus 1.5. So how much you have to add here to get minus 1.5? Minus 4.5. Correct? No?
Yes, sir.
At which point R of, oh sorry, okay, R of t minus 2. Here slope is minus 1.5. At 4 you have to make it 0 from 4. How much you need to add now? Plus
1.5.
okay, just a minute. This is not. So I have to add plus 1.5 from which point? R of t minus 4. I think you can take the Laplace of this. 6 by
Yes.
s square minus 12 e to the power minus 0.5 s divided by s square and so on. Can you write the transform of this, everyone?
Yes, sir.
So understood these problems now?
Yes, sir.
Okay. So in the question paper also they have asked many things. So okay. So remaining problems I will just give it to you few things, or you can plot of your interest. You can plot any signal like of your interest, just play with it. You can start like this. You can come here and you may get the ramp. Just check like these things. Okay, so you will enjoy that anyway. So previous class what I told, that is very important in terms of the knowledge. So what how to model the things. This is a very shortcut method, but while writing be careful about the previous slope and present slope. So if you miss that, then entire thing will be of no use. Okay, so fine. So work on this. So tomorrow 12 to 1 again I am taking. So tomorrow, maybe tomorrow we'll wind up this subject. Okay, portion. Okay, fine. Any doubts so far?